This is pre-algebra lesson 7-5, solving equations with variables on both sides. To solve an equation with variables on both sides of the equation, use addition or subtraction to collect the variables on one side of the equation and all the constants or numbers on the other side. It doesn't matter which side of the equation you put the variables or the numbers on, as long as you isolate all the variables on one side and all the numbers without variables on the other side. Be careful, however, you might need to simplify before you move things from one side to the other. Let's solve these equations. 4c plus 3 equals 15 minus 2c. To solve this, we simply need to make sure that all the variables are on one side and all the numbers are on the other. Remember, the dividing line for your equation is your equal sign. So I have a tendency to like all my variables on the left-hand side, just because I like it that way. So to do that, I'm going to add 2c to this side, which means I need to add 2c to the left side. I now have 6c plus 3 equals 15. To solve for c, I will subtract 3 now from the left-hand side and from the right-hand side. So the 3's cancel on the left side, leaving me with 6c. And 15 minus 3 is 12. Divide by 6, and c equals 2. And of course, I should check it just to make sure that it is correct. So I have 4 times c, which we solved as being 2, plus 3. Does that equal 15 minus 2 times 2? Moving the problem 2 there, a mistake. 8 plus 3, does that equal 15 minus 4? 8 plus 3 is 11, 15 minus 4 is 11, so it checks. Always a good idea to check your problems. Let's look at problem number 2. 4x plus 4 equals 2x plus 36. I like my variables on the left side, but it doesn't really matter, but I'm going to do it anyway. So negative 2x from the right-hand side, subtract 2x from the left-hand side. And you can get rid of the numbers first and the variables second. It doesn't matter for that either. 4x minus 2x is 2x plus 4 equals 36. Subtract 4 from both sides now to get all the numbers on the other side. These 4's cancel out, and I have 2x equals 36 minus 4 is 32. Divide by 2. X equals 16. Not too difficult. All you have to do is remember to put all the variables on one side, and it doesn't matter which side, and all the numbers on the other side. Again, it does not matter which side you put anything on. Let's look at problem number 3 here. Here we go. Negative 15 plus 6b equals 28b plus 13. Right, I'm going to, again, move my variables to the left-hand side just to prove that it doesn't matter if they're negative or positive. So I will subtract 28b from the right-hand side and do the same thing for the left-hand side. That leaves me negative 15. Positive 6b minus 28b is negative 22b. And that will equal 13. Add 15 to both sides. And I will get negative 22b equals 28. To solve, I need to divide by negative 22. You're looking at this going, oh, I'm getting an ugly fraction. Yeah, you are getting a fraction. It's not that bad. If I take negative 28 and divide it by negative 22, that reduces. Right? I know it reduces by 2 at least, so b is going to equal negative half of 28 is 14, half of 22 is 11. So negative 14 elevenths. Or if you so prefer, negative 1 and 3 elevenths. I don't have a preference. I tend to leave it as an improper fraction because it's what I'd have to put it back in as when I were to check it. And you may use the distributive property to simplify one or both sides of the equation before you can get the variable alone. For example, in this particular problem, 8x equals 12 parentheses x minus 1/2, I do have to distribute the 12 through the parentheses before I can move all the variables to one side or the other. So if I distribute this 12, I get 8x equals 12x. 12 times a negative 1/2, or negative half of 12, is minus 6. Now I can move all my variables to one side and all my numbers on the other. All I need to do is subtract 12x here, 12x here. 8x minus 12x is negative 4x, and that will equal negative 6. divide by -4, and x will equal 3/2 or 1.5. You can do problems involving word problems. Again, you have to define your variables so that you can get your equation, and then you can simply solve. Steve types at a rate of 15 words per minute, and Jenny types at a rate of 20 words per minute. Steve and Jenny are both typing the same document, and Steve starts 5 minutes before Jenny. How long will it take Jenny to catch up to Steve? So we need to know how long is it going to take. So we need to know what Jenny's time is going to be. So I'm going to let x equal Jenny's time. Okay. I know that the words that Jenny can type has to equal the words that Steve can type because it says how long will it take Jenny to catch up to Steve. So eventually they have to type the same number of words. So the words for Jenny has to equal the words for Steve if this is going to work. Okay? And I know also that it's the words per minute that we need to work on. So it says Steve types at a rate of 15 words per minute, and Jenny types at a rate of 20 words per minute. Okay, so Jenny's words are going to be 20 words per minute times the number of time that she's working, and Steve is going to be 15 words per minute times his time, okay, that he's typing. So he types. If you remember up here in the document, it says that he starts 5 minutes before Jenny, so he would be Jenny's time plus 5 minutes to get to Steve's time because he got 5 minutes head start. So Jenny's words per minute, 20 times the amount of time she's typing, plus it has to equal Steve's words per minute, which is 15 words per minute, times the time he's typing, which is x plus 5. So 20x has to equal 15x plus 15 times 5 is 75. So then we need to get all the variables on one side of the equation, so subtract 15x. So 20x minus 15x is 5x, has to equal 75. Divide by 5. X has to equal 75 divided by 5, which happens to be 15. So how long will it take Jenny to catch up to Steve? It will take her 15 minutes. So solving equations with variables on both sides. Not hard. Right? You just need to get all your variables on one side of the equation and solve like usual.